Over 250 billion cardboard boxes are produced worldwide every year. From the familiar Amazon Prime packages on your doorstep to high-value export containers, they all rely on this ubiquitous brown material. But have you ever wondered how rough tree trunks from the forest are transformed into lightweight, sturdy cardboard sheets, capable of protecting goods on their journey across the globe? In today's video, we step inside a modern factory to explore the entire corrugated cardboard production process, from raw tree trunks to the finished box. Cardboard is often viewed as an environmentally friendly choice due to its recyclability and natural biodegradability. Yet, behind the hundreds of billions of boxes used annually lies a hidden cost. The primary raw material for cardboard is wood-derived cellulose fiber, meaning the industry remains heavily reliant on forest resources. Without sustainable management, surging demand places increasing pressure on forests, shrinking wildlife habitats, and degrading ecosystems that serve as vital carbon sinks. Furthermore, the paper industry consumes vast amounts of water and energy, while manufacturing processes generate emissions and wastewater that require treatment. So, in your view, is the world simply packaging goods? Or is it gradually wrapping up the planet's future? The journey of a cardboard box begins in cultivated forests, where trees such as pine, spruce, or eucalyptus are grown to supply fiber for the paper industry. Once the trees reach the appropriate size, heavy harvesters, weighing tens of tons, begin the work. The machine's head clamps onto the trunk, a saw blade at the base makes a cut, and within seconds, the entire tree is felled. Rollers then pull the trunk through the harvester head, while steel blades strip away branches and cut the wood into shorter, transportable lengths. Following the harvester is a forwarder, a machine designed specifically for timber collection. Its hydraulic arm lifts the logs into the cargo bay and transports them to a collection point, eliminating the need to drag them along the ground. Finally, a crane stacks the logs onto specialized trucks. A fully loaded timber truck can carry approximately 25 tons of wood before leaving the logging site and beginning the journey to the paper mill. Upon arrival at the plant, the logs are unloaded and fed into a massive debarking drum. As the drum rotates continuously, the logs collide and rub against one another, causing the outer bark to peel away without the need to process each log individually. The debarked logs are then fed into a high-capacity chipper. Inside, a rotating disc fitted with sharp steel blades slices the logs into thousands of pieces. These chips, typically about 1 inch long and a 1/4 inch thick, flow continuously along a conveyor belt. From the storage area, wood chips are fed into massive vessels known as digesters. There, they are mixed with a specialized alkaline solution designed to separate the wood's components. The mixture is heated to approximately 350 degrees under high pressure. The heat and the cooking solution act upon lignin, a natural substance that functions much like glue, binding millions of cellulose fibers together and providing the tree trunk with its rigidity. As the lignin gradually dissolves, the originally hard wood chips soften and begin to separate into individual fibers. Following the cooking process, the material has transformed into a dark brown pulp mixture containing the bulk of the cellulose fibers required by the mill. This soft, moist, naturally brown mass of cellulose fibers serves as the raw material for the paper layers of cardboard. First, the pulp is mixed with a large volume of water to create a highly diluted mixture, often consisting of up to 99% water. This mixture is pumped into the headbox, a large chamber designed to spread the pulp flow into a thin, continuous layer onto a mesh screen moving at high speed. Immediately, most of the water drains through the mesh, while the cellulose fibers remain behind, intertwining to gradually form a wet sheet of paper. The paper sheet then passes through large press rolls, where mechanical pressure squeezes out more water and binds the fibers more tightly together. Next, it travels through a series of steam-heated drying cylinders, causing the remaining moisture to evaporate continuously. Upon exiting the drying section, the initial wet pulp has transformed into a long, continuous strip of brown paper. It is wound around a steel core into massive industrial rolls. A single large roll can weigh approximately 50,000 pounds, equivalent to the weight of about 15 family cars. A standard piece of corrugated cardboard typically consists of 3 layers of paper, 2 flat outer liners, and a wavy corrugated sheet sandwiched between them. This middle layer is the crucial element that gives the cardboard superior load-bearing strength compared to ordinary flat paper. To manufacture it, a paper roll is fed into a corrugator and heated with steam to soften the paper, making it easier to shape. The paper then passes between 2 rotating steel rollers with meshing, wave-like teeth. Heat and pressure mold the flat sheet into thousands of continuous waves, known as flutes. These flutes create space between the 2 outer liners and function much like a series of tiny support columns within the board. Consequently, any applied force is distributed across the entire structure rather than concentrated at a single point, resulting in a material that is lightweight yet rigid and highly resistant to compression. Flute sizes vary depending on the intended use. For instance, the common C flute has a height of approximately 0.16 inches, whereas the E flute measures only about 0.06 inches, resulting in a thinner type of cardboard. Immediately after being corrugated, the hot fluted layer moves directly to the bonding section. A thin layer of starch-based adhesive is applied to the flute tips, and the first flat paper layer, known as the liner, is pressed onto the top. At this stage, the 2 layers have bonded to form a structure called single face, one flat side and one side with exposed flutes. The single-face material continues along the production line to be joined with a second liner. Starch adhesive is again applied to the exposed flute tips before the entire assembly is pressed together to form a complete 3-layer structure: liner, flute, liner. The corrugated board then passes over a series of steam-heated surfaces. The heat enables the starch adhesive to rapidly form a strong bond, while pressure holds the 3 paper layers tightly together during the process. Once the 3 layers are securely bonded, the wide cardboard strip moves directly into the cutting and shaping section. First, high-speed rotary blades trim off excess edges and slit the strip into narrower widths. Simultaneously, scoring wheels press straight lines into the paper surface. Next, a cross-cutting system separates the continuous cardboard stream into individual sheets of the required length. Depending on the specific order, dimensions and fold line positions may vary to create different box styles. For more complex designs, the cardboard sheets pass through a die-cutting machine, where a shaped die cuts out slots, flaps, handholds, or special curved profiles. Before being transformed into finished boxes, cardboard sheets are fed into a flexographic printing machine, one of the most common printing methods for cardboard packaging. Inside the machine, the images, logos, and text for each order are created on flexible printing plates wrapped around rotating cylinders. A thin layer of ink is applied to the surface of the plate, and the cylinder then presses it directly onto the outer layer of the cardboard. Because the printing plate is flexible, it can transfer the image onto the cardboard surface without exerting excessive pressure that might crush the inner corrugated fluting. The ink used for cardboard is usually water-based. It dries quickly and is compatible with the speed of the production line. In addition to brand logos, the machine can print product codes, shipping instructions, fragile symbols, and various other details. Before leaving the factory, the cartons undergo inspections for dimensions, cut quality, print positioning, and the integrity of the joints. Selected samples are also tested for compression strength to simulate the pressure the boxes must withstand when stacked in warehouses or on trucks. Once they meet specifications, the boxes are not assembled immediately, but are instead folded flat. This method allows hundreds of boxes to take up significantly less space during storage and transport. Stacks of cartons are neatly arranged onto pallets to form large units. The entire pallet may be wrapped in protective film to ensure stability and guard against dust and moisture during storage. From a tree in the forest to a box arriving at your doorstep, cardboard undergoes a journey far more complex than its simple appearance suggests. Wood is transformed into millions of cellulose fibers. Then, thin layers of paper are corrugated and bonded together to create a structure that is both lightweight and durable enough to protect goods worldwide. With hundreds of billions of these boxes used annually, recycling them has become more important than ever. Which stage of the process surprised you the most? Let us know in the comments, and be sure to hit like and subscribe to keep exploring fascinating manufacturing processes with us.